Okay, let's go ahead and take a look at the function f of x is equal to x over 1 minus x. Now, what I would do is first look at this function and note that it has a vertical asymptote when the denominator here is 0, because this is a rational function. So when x is 1, we have this imaginary vertical asymptote there. Okay. And now our behavior, as we come into 1 from the left side, values are a little bit less than 1. This will be positive, but they're going to increase without bound. So this will be positive as I come into here. And 1 minus something that's just a little bit less than 1 will also be positive there. So I know that I'm coming upward like this. I also know that I approach the value -1. And the reason I know that I approach that value is because these guys are the same power, and that's the ratio of the coefficients. So hopefully you remember that from college algebra. So we've got this line right here. I'll do it in a different color. This is our graph on this side, and this is clearly our graph on this side. Now you can check to see if it does any other weird things. Like we could take the derivative of this guy. Okay, derivative is the bottom times the derivative of the top minus the top times the derivative of the bottom over the bottom squared. So that'll be 1 minus x plus x over 1 minus x squared. And so that guy gives me 1 over 1 minus x quantity squared. Now this guy is never 0, meaning there's no mins or maxes. Local, at least. Okay. Also, we can check concavity here. This guy is always positive. Okay, it's always positive no matter what you plug in here, because this guy is positive, this is positive, this is positive, so we're always increasing. So we've got the situation where our function is always our derivative is always positive. Okay, so our function is always increasing over these two intervals, so always increasing. We can take a look at f double prime of x, okay, which is the derivative of this guy. So it's low times the derivative of the top, which is 0, minus the top times the derivative of the bottom, which is 2 times 1 minus x times -1. Okay, like that, over 1 minus x to the 4th. So this ugly mess in here, this is going to be, let me work on my inside first. This is going to be 2 times this times -1, which is -2 times 1 minus x. So that'll be a total of +2 times 1 minus x over 1 minus x to the 4th. So this will give me 2 over 1 minus x to the 3rd. So this guy again is this, depending on where we're looking, when x is less than -1 on this side, this becomes positive. So we've got this whole thing being positive, and when it's positive, we're concave up. So concave up over here. And when we get a value over here that's greater than 1, this guy's bigger than this guy, which means this is negative. Cube it, still negative, so it's negative, so we're concave down. So you can graph it out just like that.